let's dig into conversion. So I'm going to start simple. All right, so I'm going to let you guys copy it if you want. When somebody's ready, who wants to tell me what the decimal equivalent of that is?
This is binary, right?
Binary, yeah, so good. Should probably be more clear about that. Right? So, good question. I'm going to come back to that in a moment after we get past this. I want to take a stab at it. 21. It's 21. And now, how did we know that? How did we get 21 out of that? Yeah.
The way I do it is I do so on top of the ones first.
Yeah.
That's 1, and then that's 2, that's 4, that's 8, and then that's 6.
Correct. And these are the weights, right? Yeah.
Yes, the weights.
I have a question.
Sure.
When we were doing the videos, when I was watching the videos, I noticed that you're going from left to right. Is that just because of practice? Because like I was trying to do it right to left. It doesn't matter.
Doesn't matter. Whatever you're comfortable with. I like to go biggest number to smallest because it helps me add up easier, I think. But it doesn't matter because it's addition and it's going to have the same. Now, what's important, I said it's addition, but remember, you're technically multiplying these, right? And while that doesn't matter in binary, it matters in every other base, because in every other base, this can be more than 1. So just remember that, and then you're adding right this way. So I'm gonna do shorthand from now on and just throw the weights above there, but they're powers of 2. So you take your powers of 2, 16 times 1 is 1, 4 times 1 is 4, 16 plus 4 is 20, 1 times 1 is 1, 20 plus 1 is 21. The answer to this is 21 in base 10. Now, a quick note, because it's very fair to point out that I didn't denote the base right away, and I should have. I'm not going to make an extreme habit of that today, just because we're going to be moving quickly, and we should discuss normally ahead of time what we're working with. But I want to talk about the ways that you do denote the base. If you're writing it out, normally it's in a subscript here, so you just write the base smaller and down to the side of the number. You may also see it like this. That could be a way to write 21. You'll commonly see it that way when you're programming, because when you're programming, you don't have superscript and subscript and all those little doodads. You just have plain text. So the way that you denote a binary number versus a decimal one is usually 0b. A hex number is usually 0x. So a little bit of a side, but a useful one. You might actually use that in your lab because when you're assigning hexadecimal numbers, you can use the 0x to do that, to specify that. All right, so to take this back out now and make it into binary, what would my first step be? If I want to take that 21 decimal and go back to binary, we all know the answer, but how to do it?
I would just write those numbers out again, like 16, 8, 4, 2, 1.
Okay.
And then I would see if 16 can go to 21. If it does, that's a 1, and then just remainder, keep going.
Correct. So you would divide it by the largest weight you can. So 32 is too big. 16 is the first one I can divide into 21. What does that give me? That gives me the 1, remainder 5, right? I take that 5, can I divide an 8 into it? No, I put a 0. Then I take the 4, can I put an 8 into that? Or 4 into that? The answer is yes. 1, remainder 1, right? I can't put a 2, I can put a 1, I'm done. So remember the key to, I always remember it this way, multiply 2, divide away, where the thing I'm talking about is decimal. Multiply 2 decimal, divide away. And then the 2 methods you have, the standard method is by weight, which is what we've been doing. The alternative method was by base. I found that 90% of people like the standard method, but That doesn't mean there's anything wrong with the alternative. Use the one that you are the most comfortable with. Let's look at a hex one. I'm gonna get new. Want to make this short. Who wants to take a gander at what that is? The decimal. You can do it in your head, usually. Not that hard for it. That's not that hard for a head. Well, it's not. I was nice and gentle on the eggs. This needs some Jeopardy music.
Is it 24?
24. No, definitely not 24.
Oh, because you have the times that
Yes. Yes. So the easy way to do this in your head is, what's our weight here? 16. Right. And obviously this is a 1. It's always a 1. Every base is a 1 there. That's easy. 0 power rule. All right. 16 times 10 is 160 plus 13 is 73. Of course, going back the other way in hex is the same idea. Biggest base I can divide this by, 16. That's going to give me 10, remainder 13, which is a, look at that. I mean, I just assume that's correct because we did it the other way, but you can rip out a calculator and double check. All right, any questions on, yes?
I'm not sure why I'm lost. For D, that wouldn't be 16, like, why, 16 times 1 is 16.
No, sorry, this is just something denoting the base. D is 13.
Okay.
Yeah, sorry, this was just for
Right,
hex.
because 13 times, okay.
So, and I'm glad you actually mentioned that because I think I said this to all the other groups, but not you. One way I like to think about this, here are our letters in caps, right? Where this is 10, 11, 12, 13, 14, and 15. I like to do this as a way for me to pivot more easily. I remember Lucky Dog, and then I know that if it's a 13, it's a D because that's the lucky number. So I pivot from that. So if I see a C, I know one less. If I see an E, I know one more. I mean, it's not that hard to figure out, but if you want to count from 10 and think A, B, C, whatever, right? So that just gives me a pivot in the middle. All right. Any questions on conversion? Please, now is the time, because it's going to get quicker, faster, more brutal. There will be blood in the streets. All right. Okay. So let's go to binary addition. Not that hard, but we're going to skip the wimpy stuff and go to the good stuff. So, you know, I'm purposely doing 3 lines here because I want to skip the wimpy stuff. These are all binary. Who wants to take a stab at doing my first place? Yeah.
It's 1 and then carry the other 1. It's 2.
It's 2.
Yeah.
Which, how do I write 2 in binary? 1, 0. Yep. So I have 0, carry a 1. Right? So you see what I did there? In binary, this is the one I love. I just showed this one to my kids. I'm like, look, 1 plus 1 equals 1, 0. And they're like, doesn't Dad, you're an idiot. I'm like, no, it really does. And then I do this, and they're like, what? Now it's 1, 2. No way. You're my kid, I love you. All right, so that's what 1 and 1 equal now. You've been transformed into computer science students. So 0 and 1, right? Now, what do we have here? 3. So 1, 1. So 1, carry 1. right? Now things get exciting. This is why we all woke up this morning. What do we got now? 0 carry 2. What's a 4 in binary? So it's a 4, right? 1, 2, 3, 4. What's a 4 in binary? 1, 0, 0. Yep. So 1, not chalk. 1 plus 1 plus 1 plus 1 equals 1, 0, 0, right? So we have our 0. This is the important part. 0, 1. You got to make sure your carry goes to the right place. No different if you were adding big decimal numbers and carried over into the thousands or wherever, right? Same idea. If it helps, put the 0 there so you know you went over the right amount of spaces. All right. So from here, it's pretty much rinse, wash, repeat. 1 and 1 is 2, so 0, carry 1. I have 2 carries, so I like to stagger. That's just my habit. So 1 and 1, 1 and 1 is another 4. So 0, 0, 1. 1, 1 and 1 is 1, carry 1. 1, 1, 1, 1, and 1 is 5. So 101 is the answer, right, for 5. So 1, carry 0, and 1. 0 and 1 is 1. 1 is 1. And I think we did that right. Yes. Cool. All right. Let's do a shorter version really quick because I want to show you a check in a reasonable amount of time. All right. Let's say we do this. 1 and 1, 0, carry 1, 1, 1 and 1, 1, carry 1, 1 and 1, 0, carry 1, 0, carry 1, 0, carry 1. Okay, cool. I think I'm good. I'm a good guy. I think I'm in good shape here. How do I know I'm in good shape? What can I do to verify this? Yeah.
Convert them.
Convert, exactly. So I have my weights. I'm going to put them up here to keep myself sane. So I have a 16 and an 8 is 24, 26, 27, right? This one's 7, I know that by looking at it. So 34. Dun, 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 dun. Big moment. Is it 34? It is. Look at that. 32 and a 2. All right. So always check your work. Moral of the story. Because that's the only way you know you're right. This is such an error-prone process. I don't care how good you are. You're going to make errors, especially not even in this part so much, maybe in this part too, but multiplication and division is a mess. So, yeah. All right, let's do subtraction. Put an easy one on the end. What's the first place? Right, 1. That's easy. 1 minus 0 is 1 in any case. All right, now what do we do? We know we have to borrow, right? Just like any other arithmetic, we have to borrow. We're going to go over to the next place, and we're going to take from this. This is going to become a 0. What was our weight here? 4. So we actually borrowed 4, right? That's the value we borrowed. We're putting it here. So what we're putting here is 1 because it's 2 2s, right? I now have 1 0 in the 2's place. I have 2 2's, which is 4. So that's where our 4 went. Our 4 came from there and went there. It's the same in decimal. That's why you end up taking from 1, plopping it over. You take 10 from 1 and you put it over into the next place, right? So now I have this 1 0 minus 1 is 1. Okay, that's straightforward. Now I have to borrow again. Now we get to distribute it across many places. So if what I said before seemed a little off, hold that thought because we're about to do it across a whole lot of places. And then hopefully that'll help solidify it. It's one of these things that you've been doing, let me back up. You've been doing this is decimal now. You've been doing this in decimal your whole life. You probably never thought about the mechanics of it because it was just trained in grade school, right? What's happening here? I can't take from that. Okay, so I'm taking 100. What am I doing with 100? Well, I'm leaving 90 of it here because that's the tens place, and I'm putting 10 of it there because that's the ones place. There's my 100, 90 plus 10, right? We're doing the same thing here. We're taking from here and distributing all the way across. So here, let's look at our weights. 1, 2, 4, 8, 16, 4, and 128. So I am taking 128. I am leaving 64 of it here. I'm leaving 32 of it here, so up to 96. I'm leaving 16 of it here. So now I'm at what? 96, 102, 112, right? I'm leaving 8 of it here, 120, and I'm leaving 2 4s here, 128. Look at that. Does that make sense? The only part that might feel weird is leaving the 2 of something in that last place, right? Because that's what you're doing, it's 2 of something.
So right now in 4, is that equaling 2, or would that equal 4?
It's 2 4s. You're denoting that you have 2 4s in that spot. If I had only had a 1 here, I would have 1 4. But I have.
Oh, because that's a 2, this is 1 0.
Right. It's 2 4s, right? Yep, exactly.
Okay.
So that's how the 128 actually gets distributed. I mean, you just learned, it was so mechanical, right? You just did this, it was automated, but that's what you were doing. You were taking from one and distributing it to the others. In decimal, it just is more natural because when I made the 0 there, we put the 1, we had 10 of that thing. I mean, 10 is still more than you fit in that place, but we put it there, right? So it's the same idea here. This is more than we can fit in this place, but we're putting it here. That's all. All right, so we're taking, and we know it will work because we had to require it to have done the borrow to begin with. You know what I mean? There's no scenario in which this stays because we needed to borrow. Question?
So that 1 0 under the 4 weight, that means there's 2 4s there.
Yep. Okay. Yeah, I'm pointing to here now, but yes, it means there's 2 4s there now. So there's actually a real value of 8 here because what you're subtracting from it is 4, right? And then you're going to leave 1 4. 1
4, yep.
Does that make sense?
Yes.
It's probably because when you do this in decimal, you never talk about the actual magnitude of the value, it just becomes mechanical, right? But it helps when you're switching bases because it's good to understand, like, I mean, you know they're not 9s because it's not decimal anymore, but in different bases, you have to have the max value. Why? What is the mechanics of that, right? So that's the mechanics. All right, so my 2 4s minus my 1 4 is 1 4, right, or 1. Here I have 1 minus 1, so 0. 1 minus 1 is 0. 1 minus 1 is 0. 1, that was erased, so 1. And that one went away. So there's our answer.
So essentially, we're pretty much saying, like, if we're looking at the 32 8, it's like 32 minus 32. That's 0.
Yeah,
And that's
exactly.
how it works.
Yep. It's just you probably never thought about it that way.
Right. Yeah.
Because you weren't taking the weight into consideration. And the only reason I'm doing it is to be explicit about how borrowing mechanics work, so you can apply it in any base. All right. Any questions on the subtraction and the borrowing? Now, the addition and subtraction themselves are not hard. What you have to remember is that when we go into multiplication and division in a little bit, you have to reapply them because at the end of the multiplication and division, you have to use these skills. All right, let's flip really quick to another base. Let's do this chalk, but it just messed up. All right. So let's do 3AC minus 2F. It's pretty simple. We're just going to make sure we're okay with what we got to do in a different base. So we can't obviously subtract F from C, right? What's a C?
13.
12.
12.
Lucky dog is 13.
Lucky dog is 13.
12 and 15, right? So this isn't enough. We need to borrow from here. What's A going to become? 9. Right? So what did we borrow?
16.
16, right? So we still denote that because we added 1C, right? If we multiplied this out, 1 times 16 is 16 plus C, right?
So that 1 is a 16.
Correct, because this.
Okay. So, so it would be B then, because it would be adding 1.
Right. So it would be D because you're taking the 1, and that's what you mean by adding 1, right?
Yeah.
Absolutely.
Okay.
Yes.
So it's like you're doing like 28 minus the 15 now.
Correct. If you want to convert it out, 20, you're doing 7. Wait, hold on. You're doing this is 7. All right. Oh, you're right. Hold on. 16 plus 12 is, yes, 28. And then minus 15. If it helps, by the way, to do this, to convert it over to decimal, have a field day, just remember to bring it back. I very rarely convert out to decimal when I'm doing addition and subtraction because the numbers are usually one place and small. However, when we go to multiplication and division, we're going to be doing this all the time. But yes, you're absolutely right. This is another way to do it, which still gets us to D. You just gotta make sure you do that conversion back. Now the rest of this is straightforward. 9 minus 2 is 7, and then we bring down our 3.
So what do we call that 37D? Or
37D.
You would say.
So to avoid putting any vernacular into it that has to do with decimal, because if you say 370D, you're talking in decimal,
Yeah,
because you said 100 and, right? So I always just say that the number is 370, or I try to, yeah.
So I'm trying to look at that, the 1C minus F in my head, and I'm getting a little confused. Like without even doing that side stuff, I'm trying to see how can I do it in my head.
So because this is 1 less than going into the next place, that's what he was talking about, what they add 1. So essentially you can look at the difference between C and F and add 1. Because this is, it's the same as doing this, right? If I have 17 minus 9, this is decimal now, right? Just to help us visualize it. Because I know I'm 1 off from 10 here, right? I know that the difference is essentially 8 because I can eyeball it and see that. And that's what he did here. That was the same kind of thing. It was the difference from the whole number applied to the difference between them. All right, any questions on that? There should have been a math teacher. Missed my calling. All right, let's. Yeah, right. Nice try. All right, so this part now, unfortunately, lost my sheet I printed out, so I don't want to mess these up, so I'm going to come back to this so I don't. Let's start small though, before we even get there. Let's start with all right, this is all binary, of course. What is anything times 1? Itself. What is anything times 0? 0. Multiplication of binary is super simple. If I have a 1 here, my answer for this first row is what I have, right? So 1, 0, 1, 1, 0, 1, 0. Now my next one is obviously a 0. What do I do before I even think about that 0 though? What do you do in long form? The placeholder. So I'm going to use an X just to be super clear that it is the placeholder, but it doesn't matter. Obviously, a 0 is fine too. Now, you have two options. You can write out the zeros, go back down here and do your new placeholders, or you can just add another placeholder because it was all zeros and it doesn't matter. And if you don't believe me that it's the same, watch them. It'll be the same. So that's basically dealing with this. Now I'm going to take this one, multiply it by this again, which means I'm going to write this out. Just make sure that you keep everything lined up, and you'll be okay. Right. Makes sense?
Because you're gonna bring those 0 placeholders down as well.
Right, so
instead of
let me,
doing
yeah. So what I did here was essentially this. I had this. I could have done this, and then done this. I think I missed a digit here, I'm sorry. But I think the idea is,
No, that's right. 0
Yeah,
placeholders,
one of
0
those.
placeholders.
one of them I missed a digit, I think. But the idea is the same, because this is ignored. You don't even need it. So what I did is I skipped down here, right? So that's what this is. Now you just have to add them up. So again, if this was longer form multiplication, you're going to end into many of those carries where it carries over multiple places. This isn't that one because there's only 2 things here, so you're never going to carry over one place. So that's fine. So 0 comes down, 1 comes down, 0 and 0 is 0, 1 and 1 is 0, carry 1, 1 and 1 is 1, oh, sorry, 1 and 1 is 0, carry 1, 1 and 1 is 0, carry 1, 1, 1 and 1 is 1, carry 1, 1 and 0 is 1, and 1 comes down. And that should be your answer. Feel free to verify any of these later, and if I messed any of them up, let me know, and I'll let the whole class know. It would likely be some silly error on my part, scratching up the board, but I don't want to kind of wreck the flow by verifying them all. So we're going to keep moving ahead. Let's throw an octal in the mix just for getting it in there. Let's do. All right. Who wants to start me off? You can go to decimal first. That's perfectly good. I'm going with 2 remainder 5 or 2, 5. Anyone else agree? We're going to do the math to make sure I'm right. Let's see this. So what's 3 times 7 in decimal? 21. What do I divide it by? 8. So I have 16 is obviously my biggest whole number multiplication of 8s and 5 left over. So you end up with 2 remainder 5, which is the same as saying 2, 5. This one, you should be able to do without conversion.
It's just 11. 3 times 3.
Well, it would be 11, but I think you forgot the 2. I think you forgot the carry. So 3 times 3 would be 9, which would be 11, it would be 1, 1. But the 2 was in the mix, so you have to add the 2 in and then do it. So it's actually 3 times 3 is 9 plus 2 is 11, then you do it. So it was 1, 3 is the answer, right? Let me rewind and do it because I see some bewildered looks. So 3 times 3 is 9, which is obviously over, but we're not done yet. Plus 2 is 11, divided by 8 is 1, remainder 3, right? So it's just that you had it, but you just forgot that guy.
I just forgot to divide by 8, that's what it is.
No, you divided by 8 because you stopped here. You had 9 divided by 8 and ended up with 11.
Okay.
You forgot the 2. You forgot the carry from the previous one. So now this is 1, 3. 2 times 7 is 14. Divide that by 8. Yep. I highly recommend always in multiplication, stagger your carries, regardless of whether there's something like it so happened there was one above the other, but even if there was nothing here, I'd still put it on the second line. Because you want to remember which line you're on at any given moment when you're dealing with carries, and you don't want to accidentally bring a carry in or forget to, right? So just create a new line up there. So now I have 3 times 3 is 9 and 1 is 10, which in octal is.
Wait, isn't it 2 times?
Oh, sorry, thank you. 2 times 3 is 6, plus 1, we don't even have to do anything. That's a number. 7. Thank you. See, I went over there and I was going off the wrong one.
So if you can't divide by 8, you just drop down the number. So like 7 and below.
Yeah.
Just drop down.
If you can't divide by 8, then you didn't exceed the number of values in that place and you're good.
Therefore, it's in the 8 to the 0 power place.
Correct. Yeah. Just like if you had added, 3 and 5 in decimal and brought down an 8. You didn't have to worry about going over the next place. All right, now we're going to do the addition here. This one's pretty straightforward. We got a 5. What's the 3 and the 6?
1.
Correct. 1, bring over 1, right? 9 divided by 8. Hopefully, soon you'll get comfortable enough with these single-digit places to just do that in your head without having to really convert it. 1 and 1 is 2, and 7 is, which is 1, 1. There's our answer. All right.
So if you divide by 8, do it, and then carry over the remainder.
Right. Exactly. Yeah. The remainder will actually stay where it is, and then the whole number will go over to the next place.
So the remainder stays.
The remainder stays. So like when you had 9 and you divided by 8, you ended up with 1 remainder 1. It's this one. I mean, I'm going to do it with one that's not the same.
Yeah, that's why I got confused.
So 8 goes into 10 once
Right.
to the remainder of 2. The 2 stays,
2 stays.
a 1 goes over.
Gotcha.
All right?
Because it's an 8, that makes sense.
Right. Okay. Any questions on that? We're going to jump into the big boy now. We're going to do hex. All right. All right, so like you, but the wax is killing me. All right, here we go. 1, A, F, 2, 3. No, 2, 7, 9. I'll give you a moment to record. All right. First one's pretty easy. 2 times 3 is 6. Awesome. We're off to a good start. 2 times 2 is 4. Still cruising. 2 times F.
So it's 15.
Yep, it's 15.
It's 30.
Yep.
So 30. 30 divided by 16.
Correct.
remainder of 14.
Right. Which in 14 is in, counting F, is an E. So we have E, carry 1. Here, I'm gonna do my first row of carries. I can fit it there. Next one's 15. I can tell you that in my head. How did I get there? 1, 5, I should say. I shouldn't say 15. That's a decimal reference. How did I arrive at that conclusion? Who wants to take it?
I'll take a stab.
Sure.
So 2 times A is 20.
Right.
20 plus 1 is 21.
Right.
And then 16 goes into 21 once.
Correct.
Remainder of
5. Correct. Everybody okay? Yep. And that one was relatively easy for me because A is easy. A is 10. Right. So any multiple you put here is kind of easy to figure out. So all right, this one's pretty straightforward too. 2 times 1 is 2, plus 1 is 3. No carries, no S. All right, next one's easy too, because I like you guys, and I put a 0 here. So, right. Now we're good. Now we can deal with one that I don't like you guys. This one's mean.
So this is the lucky dog.
This is the lucky dog. So everything's times 13. So
We're divided by 16 is how you started.
correct. So for these, I highly recommend don't even try to mess around doing it in your head in hex. Just go to decimal and then remember to go back. All right. So 13 times 3 is 39, as was duly noted. So 39 divided by 16 is 2. The remainder is 7, right? Yes. So we take our 7 and we carry our 2. Remember, even though nothing's here, I'm still going up here. I want to be clear on which line I'm doing carries from. 13 times 2 is 26. Don't forget this, so 28. 1 remainder, 12, right?
Those remainder.
Plus 2. You add 2.
Oh, yeah. Did I forget the carry?
Yeah. Well, 20, yeah, because 28 divided by 16 is 1 with 12 left over.
Oh, yeah. I did 26 as well.
Yep, forgot to do again.
Yeah.
So 12 is C. So I have a C down here. Carry my 1. I heard I gasp, and yes, it's painful. So now this is where I give my calculator speech. So calculators are allowed for all of this, midterm and quiz included. The one caveat is it can't be a phone or a tablet or an app-driven device calculator where you can go to Google and Google hex to decimal conversion. All right, it's got to be an actual calculator. Now, let me show you a trick with this thing. Well, actually, I'm going to save the trick for later when I have a fraction to actually show you. Right now, I don't yet, so we'll come back to the trick. But the answer to this mess of 13 times 15 is 195, but we have that 1 up there, so it's 196. So I'm going to bring this one over here. 196 divided by 16, I'll save us the agony, is 12. And this is where I get to tell you about the cool trick with the calculator. So 12 and a remainder. Now, the problem is that if you use a calculator, a lot of generic type calculators will only give you a fractional response. So, for example, the number 196 divided by 16, this says 12.25. Now, it's not hard to figure out a quarter of a 16 is 4, right? That's not hard to figure out, but some of them are not so easy And you want to make sure that you know exactly how to deal with this. Now, luckily for this one, if I hit equals, it actually says 12 1/4. Again, a reduced fraction, but if I know I got to get that denominator up to 16, then I can multiply the upper half and get to the right result. But the absolute best way to do this, so that you know you're always correct, is to subtract the whole number. So I subtract 12. So 12.25 minus 12 is 0.25. And then you multiply it by the base you're going to. So you multiply it by 16, and you get to the right piece you need, which is 4. That's my remainder, is 4.
Can you repeat?
Yes. So once you have the answer, if it's in a fractional or a decimal form and you want to go to a fraction, or the remainder, you subtract the whole number. So for this example, it was 12.25. I subtract 12, I end up with 0.25. You just need the fraction. That's the end result. You then multiply the fraction by the base. So for base 16, we multiply it by 16, and that gets you to 4, which is what you wanted.
So 12.25 multiplied by 16 is what you're saying?
0.25 multiplied by 16. So you subtract the whole number out, and then you multiply the fractional part by the base. Right.
Or the base.
Yep. And then once you've done that, you have your answer, which is what you wanted, which is 12 remainder 4. So 12 we know is C. So we have a 4 down here, and our C carries. So our C goes up there. Because why not? It's hex, right? That's a legit value in hex. All right. This one's actually, I won't ask you to do the hex part in your head, but you should be able to do the decimal in your head. Anyone want to take a stab at it? I know what it is already. It's my favorite number with another number in front of it.
42 is your favorite number.
So what other
Yes,
number
it is.
What other number would you put in front of it? A 1. It's 142. How did I get there?
It's your favorite number, 42.
Yeah, how did I know so quickly? It wasn't because I memorized it. How did I know so quickly? How did I get that accomplished?
So you multiply D with A, which
Right.
is 130. And
Right.
C is 12.
Exactly. So the trick was just because it's an A, it makes it easy, right?
Right.
A is 10. So you know, 130 right here plus 12. That's not so bad. All right, so we got 142. So we gotta go back out with this. I'm gonna save us the misery. 142 divided by 16 is 8 remainder 14. 14, of course, is an E.
I did that calculator.
Cool, awesome. So now we have E down here. Carry 8. Wait, I messed something up.
Is it not, is it 14 remainder 8 or is it 8 remainder 14?
Oh, shoot, yeah, it's 8 remainder 14. But I did that, so E is down here, and 8 is up here.
Oh, yeah. So it would be, E that got brought down, but then the 8.
Right. The answer is always in order. So it's like this. So you leave what's in the place where you are. This carries, right? All right, so now we have the last piece of this, which is 2 times 1, or D2. D times 1 is 13, plus 8 is what, 21, divided by 6 is 1 remainder 5. I hope I'm sorry if I'm going quick now, but, right, 21 divided by 16. The answer is 21 in decimal divided by 16, 1 remainder 5.
I got that.
Okay, so just,
Are we good where we left off? Like, is this a good?
except for division. So
Okay,
the division is like this, but worse. So practice the division.
It's in the videos?
It's in the videos.
Okay.
Yep, there's like that whole hexadecimal division one.
So this isn't the division then, what we've been doing, like how we've been getting 1 remainder 4.
Well, you're doing division to do the conversion, but we're actually gonna do a division problem.
Gotcha. All right, thank you. I'll
Yep.
go first.
You too. All right, so these now get added up. The 4 and the 6 come down. E, remember, is 14, 7 is 21, which gives me the same 1 remainder 5 again. So I'm gonna have a 5 down here, carry the 1. 1 and 5 is 6. C is 12, so I have 18, so 2 carry a 1. I have some looks. Whenever I get to 6, 18 divided by 16, so 2 carry 1. This is easy. Not easy. Yay. 8, E, 5, 1. All right, let me see if I did it right. 1, 5, E, 8, 2, 5, 4, 6. Yes. Yay! We got it. All right. Any questions on the misery? All right, so the last installment of misery. Actually, does anyone not have this down yet? I don't want to delete it, but I want to keep close to my monitor. All right, I'm going to delete it. You can now forever hold your peace. All right, we're going to do some long division. We'll start with the easier stuff to go through the mechanics. So I know long division was your favorite part of 3rd grade, or whatever grade it was for you. How do I start? Who wants to take a stab at it to get me going? What do I divide into what? Yeah.
See if 11 can go into the first placeholder.
Yep, so I'll see if 1, 1 can go into the first. So what is 1, 1 in decimal? It's a 3, right?
It's 3.
So if it helps you think about it that way, don't be afraid to convert it in your head. Can 3 go into 1? The answer is no. Can 3 go into 1, 0, which is 2? The answer is still no. Can 3 go into 1, 0, 1, which is a 5? The answer is yes. So it goes in 1 time. It'll always be a 1 or a 0 because it's binary. So there's that. So now we multiply it back out. Right? We have the 1 at the top, and we take the 3 and we multiply it by the 1, and we bring down our 3. If it helps you to just keep it in binary terms and say 1 times 1, 1, and bring down a 1, 1, how about it? I'll go back and forth between them. Right? So we divided this into this. Oh, except I made a mistake here. Right? I don't need the placeholder, but make sure you put them under the right place or you're gonna mess yourself up. So, because we went back to this place, right? So we went into 5 once. 1 times 3 is 3. Now we subtract them out. So 5 minus 3 we know is 2. But let's do the subtraction in binary like we did last time, right? So 1 minus 1 is 0. We need to borrow. 2 minus 1 is 1. We still ended up with a 2. Now, the last kind of unique step for division is you bring down the next one, right? So you might remember this. You had your arrow, and you brought down your next one. And now I ended up with a 5, which is convenient because it's going to repeat the pattern. So we know that our 3 is going to go into our 5 once. We're going to multiply this out to get our 1, 1. We're going to subtract. Again, the result is going to be a 2 because we already did this and we know the answer. But now what's changed is we're not going to bring a 1 down. We're going to bring a 0 down, right? So the 0 comes down. What's 1, 0, 0? 4. Can 3 go into 4? Yes. So we're going to put a 1 up here. We're going to multiply out. So we bring our 3 down. We subtract. So let's just do our borrow and do it like it's meant to be done. 1, 0 minus 1 is 1. 1 minus 1 is 0. The other one's gone. We bring down our last one. Good news. It wouldn't always be good news, but it's good news today. 3 into 3 goes into 3 once, and only once. Let me bring this up top here, just for clarity, because I know I'm getting down to the bottom of the board. I have 1 times 1, 1, which gives me 1, 1. I subtract them out and have remainder of 0. So the answer to this is 1, 1, 1, 1, remainder 0. Now, you won't always have a empty remainder and make no promises. Odds are I'm going to pick numbers at semi-random, and the odds of me getting one without a remainder is like infinitesimally small. Maybe not in binary, but in hex it is. So, you know, just be aware, but it's okay. There's nothing special. You would have done this math and there would have been a remainder and you would have wrote it. We'll get to fractions at the end of this class, but we're not going to use them in the math. We're not going to torture you that way. We're going to talk about fractions for their importance for conversions and what that means for precision and how we understand what the weights are, but that's the extent of how we'll deal with fractions. All right, I'm going to do the big kahuna now. We're going to do a hex division. Any questions on this before I move on? All right. There is also a sheet on iLearn in addition to the videos, by the way, that's like a practice sheet that has more examples that you can use and practice from. All right. Go a little higher, I'll put my answer up there. I promise not to make them worse than this. This is about as big as, you know, give or take a digit. I'm willing to even grade. All right, can 9 go into 7? No. So we know 9 can go into 7a by looking at it. Now here's the problem with division. Multiplication, we constantly had to go from the decimal equation that we could usually do in our head back out to hex, and we had to do the conversion there. Here, we have to do both. We have to figure out what this is in decimal to do the division, and then we got to bring it back to hex. All right? So the first step is to figure out that, right? So I'll save us a lot of time. The answer is 122. Base 10. Right? So I did 7 times 16 plus 10. That got me to 122. Now I can do the division. So now I take my 9 and I divide it. The answer to that is 13 with a remainder. Now, because I'm doing this part where I'm figuring out the answer, I don't care about the remainder. That can go away. All I care about for this part only, is that. So the first digit up here is a D. Now, I have to do the multiplication, D times 9, to figure out what I put down here, right? Yeah, me too. So D times 9 turns out to be 7, 5 in hex, but it's 117 in decimal. So if we do 13 times 9, we get 117. We divide that by 16, and we end up with 7, 5. 7 remainder 5.
Why are we multiplying 9 by D 13?
So because we don't, so think just if we back up to just hex multiplication,
Yeah.
right? If we were to do that, we'd say, I don't want to do that in hex. So I'm going to do 13 times 9 in decimal, which is going to give me 117, and then I'm going to divide it by 6, which is going to give me 75, right? So that's what we just did there. It's just that now with division, you got to do it both ways. You got to do it to divide, and then you got to do it to multiply to get to the next step.
Oh, so it's like 2 things.
Right, exactly. So that's what you got to keep straight. That's why I'm saying this is practice. It's all practice. Nothing other than practice. So we got that. We got the 7.5. So the 7.5 goes here. The only easy part. Anyone want to take a stab at what subtraction will be?
Just 5.
Yeah, just 5, right? Because it's an A and a 5. So yeah, it's 5. And then we bring this guy down, and now we got to divide 9 into 5, 5. But to do that, we got to know what 5, 5 is. So we're going to do 5 times 16 plus 5, right? To get us our decimal number. So that equals 85. So 5 times 16 plus 5 is 85 in decimal. Now I'm going to divide this. So I'm going to divide it by 9. And that gives me 9 and a remainder. Again, for this part, I don't care about the remainder. I only care about the 9. The 9 comes up here, because the remainder, remember, is going to get dealt with at the end. That's what we're figuring out here. That's those fractional parts, that's what's appearing in here. And it'll continue to count down that path until we get to the end, and it's left over. 9 times 9 in decimal, that one's easy. Remember 81, right? Multiplication tables. So now we're going to go, let me make some space over here. So we're going to have 81. If it helps you to denote everything with the base, do it. Keep it straight. Divide it by 16. The answer to that, I think, is 5.1. Let me just double check. Yeah, should be 5.1. So 5 remainder 1. Which means that I'm putting a 5.1 down here. 5.5 minus 5.1 is 4. I then bring down my D. 4 times 16, 64, plus 13, 77, right? Did I do that right? Yes, I did. Yeah. I even have 2 cups of coffee today. It's amazing. All right, 77. Now, the 77, we have to remember to divide, right? So 77 divided by 9 is going to be 8 in some fractional number I don't care about. 8 remainder, who cares? The 8 comes up here. And then we do the 8 times 9, which is going to get us, what, 72? 72. Yep. So 8 times 9 is 72. Base 10 again. We got to go back to base 16. 72 divided by 16 is, I forget, I'm going to look at my sheet, is 4 with remainder 8. So down here we have a 4 and an 8. So D is 13 minus 8 is 5, so we're going to have a 5 left over. We're going to bring down our 1, and oh lucky day, we've seen this number before. Does anyone remember what the hex version of 51 is in decimal? 81. 81. That's right. We saw that one before up here. So our 51 we know is an 81 because we've done this before. So 81 base 10 divided by 9, full number. I'm getting excited. Very exciting, it's a 9. So that means that our answer up here is a 9, which means that 9 times 9 in decimal is 81. What's that in hex? 51, which means that this is not going to have a remainder either. Almost like I planned it that way. All right. I will tell you right off the bat, don't worry, there's always partial credit. And partial credit is, if I see that you know what you're doing, then the partial credit is very generous. It's not, I'm not out to zing anyone because they messed something up. Just remember, take your time, check your work, and the key here is practice, because especially with this, it's just so many back and forths, right? All right, the last thing to talk about, we don't need a lot of time, which is good because we don't have it, but the last thing to talk about is fractions. So in decimal, if I have 1, 2, 3, dot, 4, 5, we know our bases here are ones, tens, and hundreds. What's my weight here? 0.1, which in fractional terms is 1/10, right? So here, my weight is 1 over 10. Here, my weight is 1 over 100. All right? That's pretty straightforward, but it's good to level set. It's good to know where we came from to better understand where we're going. So now, let's look at binary. So in binary, here my weight is 1, 2, and 4. On the other side of the decimal point, who wants to take a stab at what my weight is there for the first digit? Yeah.
1/2.
That's right. It's 1 over the base, right? It's 1/2. Just like this was 1 over the base, right? So power of -1, power of -2. Power of -1, power of -2, power of -3. I can keep going on and on and on. Right? Base 16. Here are my weights. Let's do F, C, who cares? Let me move into torture. All we need is this. What is this? 1/16. Exactly it. The next one would be, what, 256? Right? 16 times 16? Yeah. Et cetera, et cetera, et cetera. Right? So it's the same idea. So you're going 16 to the -1, 16 to the -2, 16 to the -3, et cetera, et cetera. Just like here, you did 10 to the -1, 10 to the -2, 10 to the -3. So that's it for the weights. Now, this has an important implication though, which can be summed up very concisely as such. You probably remember the most famous repeating fraction, at least I think it's the most famous one, right? 1/3. 3 is forever. We're going to introduce a new base today, just to make things fun, for about 1 minute. Base 3. What would my first decimal place be in base 3? 1/3. So how would I represent this thing in base 3?
1.
Just 1. And guess what? It doesn't repeat. It's a finished thing. These are the same. So if you've ever heard of computers losing precision, it's because when you're flipping bases, and I use this because it's an easy example, but it happens all the time going between decimal and binary. When you're flipping bases, fractional amounts change with whether or not they terminate or not. So that's where that loss of precision comes from. We're going to talk next week about ways to mitigate that, like binary coded decimal, floating point, yada, yada, yada. But for now, that's what you need to know. And there was another video that I released late and sent out an email about, which talks about quick conversions. So just in case, let's see if anyone saw it. How do I make this into binary? And yep, so what is the first 4 gonna be? Who wants to take a stab at doing this in their head real fast? 0, 0, 1, 1, and what's the last? What's A gonna be?
1, 1, 0.
1, 0, 1, 0. Alright, if you're not sure how that happened, that one's a quick video, it's like 8 minutes.
Why did you add the 2 zeros?
Because I wanted to keep it to the right number for one hex digit. Because a hex digit can be explained in any 4 bits, which is why we use hex. It's the whole point of like hex and octal.
So if it was octal, it would only be 2.
It would be 3. Well, it would be 1, 0. That would be the octal digit 3. A would be irrelevant in octal.
Well,
But for 3, that would work. It's 3 bits represent 1 octal.
yeah.
The range is the same. Yep.
Okay.
All right. All right. Be free. Don't multiply today.